So, we begin Managerial Economics 19. The topic is consumer behavior, which is just the fundamentals of consumer theory. Consumer theory. So, this is resuming it, right? Okay, so what is consumer theory? Well, this is an economic theory which attempts to explain consumer behavior. What does it mean to explain consumer behavior? Is, if you remember from lecture number 1, what is economics about? Economics is about decisions. How, in this particular case, consumers make economic decisions. What they buy, at what prices, and what not. Like any theory, if you remember, like any theory, consumer theory has assumptions. And this is what the first section is. It is about assumptions. So we draw a line. The chapter is, from the latest edition, 5. So, section 5.1, assumptions. Let's begin to do some of those assumptions. Well, the first fundamental assumption is utility maximization. So, utility is the benefit which consumer derives from consuming goods. Utility maximization means that given the money that the consumer has, we call it the budget, given the money that he has disposable, consumers always try to maximize their utility. In other words, this is the basic concept of getting the most out of your money. All right? You want to get the most, get the best, you get the highest value out of your money, and this is the first fundamental assumption. This assumption simply says, if you have some money, you're not going to be throwing it away. You're going to be using it to the best possible way. All right, so let's see. The second assumption is fairly straightforward. No saving is allowed. Turns out that we can derive the complete theory by not allowing any savings. When we allow savings, it turns out that the complete consumer theory does not change. In other words, all results and all conclusions follow identically when you allow savings. In other words, to derive the theory, we use no savings assumption, but we call it relax the assumption, and when we relax the assumption means we allow savings, results and conclusions don't change. Alright, is that clear? Turns out that we also do not allow borrowing too. No saving and no borrowing. With borrowing, the results are identical. The assumption which we make, he said, is not restrictive. Not restrictive means, again, when you relax the assumption, you continue to get the same result. Well, once you allow saving and borrowing, sometimes you enter into the consumer theory of actually in corporate finance. Usually corporate finance allow consumption with borrowing and saving. And they step entirely on managerial economics or in micro theory. So we make this simplifying assumption to get to basic results. The next assumption is that consumers are completely informed. In other words, consumer understand the product, they understand the value that they get from the product, They understand the reliability and everything else about the product. They know the pricing of the product and the pricing of competitive products. So, when we are recording with Panasonic video camera this lecture, the assumption is when I purchased the Panasonic, I also knew the prices of Sharp, Toshiba's, Sony's, and whatever the other brand names of cameras are. I understand well the features between the different cameras. I understand which features I really need, and I made a rational, we call it informed choice. Informed. So, this is what it means, completely informed. Well, in reality, of course, most of the times, consumers are not that well informed. An informed choice is when you go on a regular basis to McDonald's or Burger King, you're using 3 or 5 different types of meals, you know the meals, you use it for a 5th or 15th time, you make an informed choice. For example, I have been making, while here in Saudi Arabia, tons of uninformed choices about food, right? I don't know anything about Saudi food, so what I do? I experiment. What does it mean, experiment? Try. No, it means I make an uninformed choice. They tell me some food, I have no idea what this food is. Say, how much does it cost? He says 10 riyal. Okay, let me try it. Give me one for 10 riyal. I may like it, get some more the next time. I don't like it, I can throw half away. But it is clearly an uninformed choice. Well, that's what experimenting with different types of product is. I mean, for women it might be, I don't know, lipstick, whatever. So, completely informed. Within the completely informed, sometimes it is provided as separate, I don't want to get into the technical details, is the so-called perfect knowledge. Perfect knowledge. Some people consider that having perfect knowledge is the same as making completely informed decisions. Some people find any differences. For our basic fundamental decision making, for what we're trying to do, it is irrelevant. We allow, we let experts in information theory, information economics, to argue, and they publish thousands of articles. It's all about the articles. For all of our purposes, we understand that consumers have perfect knowledge when they make their economic decisions, when they act. Well, the economic decision, of course, is a purchase and a consumption, right? Let's see what else. Now we move to consumption bundles. Alright, consumption bundle is not yet an assumption. Consumption bundle simply means a set of consumer goods which are valued together. The simplest example of a consumption bundle is McDonald's meal. Alright? The sandwich with the Coke, with the fries, all goes together for the price of 10. So this is simply the meaning of consumption bundle. No assumption yet. Now I'm going to make a few consumptions. Few assumptions. So 5A is that ranking of consumption bundles is complete. What does it complete mean? No, complete means meals. You're offered meal A and meal B for the same price. You can always choose the one or the other. Alright? So, complete means for any bundle, for any set of bundles, you can always compare any two. Alright? It simply means you're going to make a decision. You're able to make decisions. That's all it means. It means if you have A, B, C, and D, if you pick A and C, you can compare and say, oh, I like A to C. We pick C to B. In other words, any pair that you pick, you can actually compare. Compare means which you prefer more or which you prefer less. Alright, the next assumption is that, again, consumption bundles, in this particular case, we call them preferences. Sometimes we'll call them preferences. Preferences are, let's see, before transitive, okay. Transitive. So, now let me get back to provide you the technical definition of complete. When you have any two, A and B, it is either that A is preferred to B, this is a sign for preference, or that B is preferred to A, or that neither is preferred to the other, which means that we call this sign indifference. Indifference. So, we say, that's just a definition, that a consumer is indifferent between A and B when he neither prefers A over B nor prefers B over A. So complete means for any two, whichever you choose, he can say it's either A is preferred over B or B is preferred over A, or I'm indifferent. So choice 1, choice 2, and choice 3. And in other words, complete means he will choose one of the three, but there will be always one, and exactly one. He can't choose possibly two of the three. You choose one and only one of the three. Okay? Now, transitive simply means if I prefer A over B and prefer B over C, so if I prefer A over B and a plus sign for and B over C. Yes, it follows that I will always prefer, given these two preferences, A over C. That's it. So, transitive simply means or implies, if I prefer A over B, B over C, C over D, that I prefer A over D. Alright? It also could, we could go a step further. If I prefer A over B and am indifferent between D and C, here's just, for example, A prefer over B and B indifferent to C. It follows that I prefer A over C. Okay? Now, this is the definition. And this is like a theorem. This is like a property. Alright? So, preferences, consumer preferences are, in this particular case, complete, we can kind of like call them, in simple English, rankable. Anytime you're given two, you can rank the one over the other in some manner. Transitive. Let's see what else we have. And here is another assumption. More is better. So, the next fundamental assumption is that consumer goods are goods. Does it mean a good? Huh? No, good means that more of that particular good is better than less of that particular good. Well, is it possible when more is worse?
Yes. Yes.
Yes, an example? Environmental pollution. When you have more dust in the air and more pollution in town is worse than less pollution. So pollution we call economic bad. Economic bad. More is worse. All right? So it's actually a definition. That's how we define economic good. Economic good is defined always as more is better, and therefore you have economic bad, which is defined as more is worse. More is worse. In other words, this is economic bad. In other words, an economic bad actually lowers your utility. And the more you have of an economic bad, the lower your utility. So, what this is simply saying is that our theory is using only economic goods and we do not consider economic bads. In other words, we could possibly extend the theory to economic bads, but now we're making, and remember, like some of these here, no borrowing and saving, we call these, from lecture 1, simplifying assumptions. A simplifying assumption is just an assumption which makes the analysis simpler and easier to use and to illustrate, but when you relax it, the result fundamentally does not change. And the type and nature of analysis doesn't change. So, more is better. Fundamental assumption. Alright, so what else is, assumption number 7 is that people actually derive utility. So, first of all, this is the more fundamental assumption of this one. First of all, it simply says, when people consume, they get an utility. Of course, this is elementary, this is trivial. Of course it exists. But what they say is that there is utility and there is moreover a utility function. In other words, utility based on 2, 3 or n goods or even one good can be represented as a function. So, let's try to delete this piece and explain right out exactly what I mean. I simply mean that a utility function exists. In other words, there is. It is representable. In other words, the utility that people derive is representable with a function. That's what it says. So this is the more fundamental, and of course, once you already assume that there is a function and the function exists, then we assume separately that consumers now, that they have a utility, that they actually maximize it. In other words, this is the underlying, and ideally I should have put it as assumption number 0. Utility exists, and assumption 1, utility maximization. Of course, it is impossible to maximize unless it exists in the first place. So this assumption is actually built into this. Alright? Straightforward questions?
Is it utility function, is it equal for all people?
The answer, so the question is utility function equal to all people? And the answer is no, certainly not. For example, remember from last time or a couple lectures ago, pork enters into my utility function and your utility function is radically different.
Yes.
I eat pork and that's okay, you don't. And for you, pork is economic bad. Actually, eating pork is really bad for you, right?
Yes.
Right, okay. So, for me, pork is economic good, and for you, pork is economic bad.
So how can we use a utility function for all people, for all consumers?
Okay, so we call this welfare utility function. In other words, what we are trying to do here is elementary microeconomics, how the individual, how I make a decision, or how you separately from me make your own decision. I maximize my own utility and you maximize yours, and every one of us maximizes their own utility. Okay? Only in the subject of, which we call public finance, we attempt to construct a public utility function where we attempt to maximize the, we call it also welfare function, we also call it social welfare function. So social welfare function is the utility of the whole society, is only when we begin to aggregate across the utilities across different people to create one larger societal utility. It's a whole different subject altogether. Most economists will say, oh, you can't just add up utility of person A and utility of person B. In other words, utility is not additive, okay? So how we add up utilities of different people, we do not consider in this course. In this course, we consider, are you going to buy perfume A or lipstick B? Okay? Are you willing to pay $20 or real for this meal or 15 for that meal? So we're trying to consider the individual decision maker. Of course, the individual decision maker would be also a family. Oops, we don't have the light on, right? For example, when the family is trying to buy a car, they buy the car, but they act as one decision-making unit. There may be 3 decision makers inside, the father, the son and the wife, whatever, but it is one ultimate decision. Is it a Camry or is it a Corolla, right? So, again, this is what we're trying to do. So what you're asking is a completely different subject altogether. A quarter of a course in public finance theory is how we construct a social welfare function, way beyond what we're not trying to maximize society's welfare. We're just trying to maximize the individual welfare. All right? Now, in this particular case, welfare is the same as utility. Utility is applied to one person. Welfare is applied to a group of people. Okay. So, we are done with section number 1, and I continue. We have plenty of time. Continue with section number 2, which is indifference curves. So, let's draw an indifference curve. This is how a macro guy draws an indifference curve. 1, 2, 3. There you have it. That's an indifference curve, right? Alright, so what do we have here? We have on this good A. Alright, that's one good. We have on this here, of course, good B. In other words, you have consumer good A, consumer good B. They could be substitutes, they could be complements. Oranges and what? Apples or bananas. Okay, it's the same story. Bananas or apples. Alright, so you have here 10, 5, it's going to be 1, again 5, 2, 10. So, what this curve simply shows is that 10 oranges and 2 bananas is the same as, it's going to be 5 oranges and 4 bananas is the same as 3 oranges and 5 bananas. Alright? It is the same as 2 oranges and 10 bananas. Alright? When I say the same, it means indifferent. In other words, the utility in this point, let's call it X, utility at point X is the same as utility at point Y, is the same as utility at point Z, the same as utility at point V. So, now I'm beginning to explain what is an indifference curve. So an indifference curve is a set of points. Sometimes we call it in English or in mathematics a locus. Locus is the same as set of points. So, is a set of points where the consumer is indifferent between any bundle on this set of points. So for any 2 points, W and let's say Y, well, it's got to be some other letter, which I'm running out of letters, S. For any 2 different points, S and W, belonging to that particular curve, the consumer is indifferent between those 2 bundles. In other words, W represents a bundle of good A and good B, and S represents a different bundle.
So he doesn't care whether he eats 5 oranges and 4
Correct. Correct. This is exactly what the indifference curve says. Indifference curve says that he doesn't care between 10 oranges and 2 bananas and 5 bananas and 3 oranges. He will get the same utility, and whichever bundle you offer, he will be indifferent between the 2. Well, here you have 1 million points, and he is indifferent between all of those 1 million points. Each point representing a consumer bundle. Consumer bundle. Right now, this graph is, we call it in mathematics, 2-dimensional. 2-dimensional. So this graph represents an indifference curve on a 2-dimensional plane, and this simply means that our bundle is made up of 2 different consumer goods. If you have a bundle of 3 goods, the indifference curve will be 3-dimensional, okay? Will be in a 3-dimensional space, alright? So, indifference curve between n goods will be represented in an n-dimensional space, alright? So, I mean, I don't want to get into, it's going to be an n-1 subspace and all those stuff. Alright, so, this is a 2-dimensional space because our bundle is simply made of A and B, alright? The set of points between which the consumer is indifferent between any bundles on or made of on that. Is that fairly clear? Mm-hmm. Alright, this is what an indifference curve is. Let's see. So, some properties on indifference curves. Some elementary properties. Proper. So, the first fundamental property is very simple. Indifference curves are always downward sloping. Downward sloping. Downward sloping represents the basic, the most elementary economic idea of trade-off. Trade-off. If you want me to get less oranges, you must give me more bananas. If you want me to get less of any good, you must give me more of the other to keep me.
Substitution, isn't it?
Substitution, yes, but not the real substitution. We just call it trade-off. Trade-off. I'm willing to give up more of one only if you give me more of the other. There is, in other words, trade-off, all right? So this is the basic idea of a downward slope. To go, downward slope simply means to get less of one. It's got to be, must necessarily be more of the other. That's what the down slope means. Okay, let's see what else. Oh, this is the one I don't want to prove or derive. That the indifference curve is convex. Convex means that it has a curvature like this. What is the economic meaning? The economic meaning here is 10 and 2, and here is 10 and 2. So here I have a 10 and 2, and here's a 10 and 2. And let's draw a straight line between them. Let's draw a straight line between them. And we get in the middle of the straight line. What is the middle of the straight line representing?
Same amount.
The same amount of the two. So it represents the bundle of 5 and 5. Okay? So, a balanced bundle is always preferred to an imbalanced bundle. Is that fairly clear? So, consuming, for example, 3 Pepsis and 3 sandwiches is better than consuming 6 Pepsis and 0 sandwiches. Or 0 Pepsis and 6 sandwiches. Alright? So when you want to have your meal, you want to have a balance between the soft drinks and the sandwiches. Alright? So this is the idea here. I'm best off by not using 10 oranges, or I'd rather not have 10 bananas. I'd rather have 5 of each. Well, some person will have 4 against 6, and another person will have 6 against 4. But the fundamental principle of convexity means, the economic interpretation is, we always prefer more balanced consumption bundles to less balanced consumption bundle. What does it mean, less balanced consumption bundle? Well, the extreme case, it means every single meal you eat the same meal. The most extreme bundle is, for example, 30 days a month, 3 meals a day, for 90 meals, you eat the same thing, sandwiches, or you eat the same thing, walnuts, all right? Or you eat the same thing, whatever it is, whatever that meat might be, rice. So, of course, no one wants, that's the basic idea, wants to have an extreme and use every time all the same. It's like music. You don't want to have 3 CDs of the same music. You want to have 3 different CDs of different music. So, essentially, it says consumers prefer variety over identical or similar bundles. In other words, variety is represented by a balanced bundle over the extreme bundles. It's just common sense and intuitive. They actually like to prove this in theory. Alright, so this is convex. Let's see what else we have. Now, number 3, it is not actually a property, but we just say, let's just say marginal rate of substitution. Do they just have it MRS? Yes. Marginal rate of substitution is, let's see if we have a measure of the number of units that we must give up from one good in order to be compensated with one of another. So, in this particular case, we must give up 5 oranges, and for 5 oranges, I'm trying to see, from 2 we're compensated to 4. In other words, we are willing to trade 5 oranges for 2 bananas. So, the marginal rate of substitution is 5 to 2. 5 to 2. Alright? Is that fairly clear? So, marginal rate of substitution is the ratio between the one good and the other good, number one. Number two, marginal rate of substitution is usually, well, almost always, because of the downward slope, negative. Alright, marginal rate of substitution between two goods must be necessarily negative. So, a lot of times, for marginal rate of substitution, we will actually use the modulus. Without a modulus, we simply say that marginal rate of substitution is negative. But when they say marginal rate of substitution is 2, they definitely mean minus 2 of the one for one of the other. Good. Alright? So, for marginal rate of substitution, you have to be careful with the sign, but it is always negative. Alright, let's see, marginal rate. Now, marginal rate of substitution can be computed over an interval. What I just did is 5 and 2, I computed it over an interval. Which was the interval? The interval was beginning at this point x all the way to y. So, what is the marginal rate of substitution? The marginal rate of substitution was this side over here, which is 5 units, from 10 to 5, or from 5 to 10, right? And this side is from 2 to 4, which is 2 units. So, marginal rate of substitution can be computed for a particular distance. If you remember back, we were calling it an arc, right? And this is an example of computing it over an arc, 2 divided by 5, or 5 divided by 2, depending whether it's oranges over bananas or bananas over oranges, right? And the alternative is to compute the marginal rate of substitution for a particular point. And for a particular point, the marginal rate of substitution will turn out to be the angle of the tangency. In other words, it is the tangency. Well, in this particular case, 2 by 5, of course, is this particular tangency over here. All right? So, if I have to be correct between y and x, it is, you see, this is a line. We draw the line over here, and this is kind of like the tangency of the almost midpoint between y and x. All right? Almost, because only if it's quite smooth and all the good stuff, it will be at midpoint, not necessarily. They could be quite curved and skewed, the indifference curves. Yeah, let's show a number of indifference curves that are skewed to the one side. Here's an example of a strong preference of skew to the one good. Like this, like this, like this. This is A, this is B. So, this consumer has a preference for which good?
B.
This consumer has a preference for B. Let's verify if this is correct. So, I'm willing to go, let's say, with 3 units, right? 3, 2, 1, 2, 3, right? And here I'm using 1, 2, 3, 10. Alright, so if I have 1 of A, I gotta have 10 of B, right? If I want to have 2 of A, I'm going to be happy with 5 of B, right? And I can live without B if I have only 3. So here's the simplest way to think about it. I can live, if I choose, with only 3 of A or with 10 of B. So the preference is over A. It's actually the opposite. So A is preferred. You see this? In other words, he's willing to live with a lot less of A than with B. In other words, if you want to cut down 1 on A, you got to give him 5 of B. All right? So here, clearly, he prefers A a lot more than B. So here's another example. Of course, that's the opposite example, where you have indifference curves like this. All right? So this is an example. Now it's exactly the opposite. B is preferred over A. That's very trivial. All right. So next property is that indifference curves do not intersect. So non-intersection. So how is it possible that two curves could intersect? Well, let's see what will happen. So this is the one curve, and over this curve, and then you have a different indifference curve for the same person, of course, and that indifference curve runs like this, right? So suppose that these two intersect, right? If they intersect, this means that at the point of intersection, the person has the same utility, right? Well, for curve, let's call this curve, well, I'm trying to come up with a name, G and H. For curve G, this point here and this point there, K, has the same utility. And for H, here we'll put L as the same utility. All right? So let's try to write it out. From curve H, this is Y. Y is the same as K. Right? For, sorry, that's from G, guys. That's my mistake, From G, Y is indifferent to K. From H, Y is indifferent to L. Okay? And from these two, it follows from, remember, transitivity, right? Transitivity, it follows that
K is indifferent to L.
K is indifferent to L. Okay? K is indifferent to L. But what can we say between K and L? Bundle K has more of good A and more of good B. In other words, bundle A has both more of good A and more of good B at the same time. So, by the assumption of economic good, which is more is better, it follows that K is better than L. Okay? So, but because K let's say A1, B1 is now better than L of A2, B2, because A1 is less than more than A2, and B1 is more than B2. So what we get is that at the same time, K is better than L. Well, this violates our original assumption. All right? In other words, in mathematics, how do we call this, what I just did? How do we call it in mathematics? Contradiction. I reached or arrived at a contradiction. I said, assume that the two curves intersect. If the two curves intersect, then it follows that the two bundles are indifferent. But it also follows by different logic that the K is preferred over L. Because it cannot be at the same time that they are indifferent and the other is preferred. We call this contradiction. So, it cannot be that these two intersect because you always get a contradiction. Is that very clear? It's just a demonstration of a proof. Please come in. Okay, let's see what else we have. Okay, well, the next concept is fairly straightforward. It is very simple.
Thank you.
You're welcome. The next concept is that of an indifference map. I already drew an indifference map, so let's define what is an indifference map. Well, you have a curve like this, so this is one curve, and then for the same person you have a second curve, and of course a third curve. And for any point, you pick a point. For this particular point, you will, or you can get a curve. And of course, this curve will be in between the two of those, because it cannot possibly intersect either of them, because this will be a basic violation of our assumptions, as I've been explaining so far. So, the set of all of these curves, the set of all indifference curves, we call simply an indifference map. That's all. So, an indifference map is the set of all indifference curves. All right? Okay, so let's see now marginal utility. Let me see how we will explain this. This is a little tricky. Now, so you have marginal utility of a good A. Let's see if I can derive this. Marginal utility of a good X, right? So this is the extra utility from one unit of X. And then you have a marginal utility of Y. This is an extra utility of good Y. Alright? So, now we can take a ratio between those two, and let's see how I'm going to derive this. Marginal utility of X, alright? Marginal utility of Y. Let's see how we do this. They use derivatives here. Yes, and marginal utility of X, marginal utility of Y, it's kind of like delta X divided by delta Y at that point. It's a little tricky. They use derivatives. Is the marginal rate of substitution. So, what they are basically saying is that marginal utility is also represented by the marginal rate of substitution. They actually have this, they use what's called full derivatives. You guys see at 168 full derivatives? You have partial derivatives and complete derivatives. 168, they say delta U equals, you see, delta utility equals to, in this particular case, we keep it to 0, is equal to full derivative mu marginal utility of X multiplied by delta X. Okay, you see this? Marginal utility of X times delta X plus marginal utility of Y times delta Y. Okay. So, it's simply the utility, marginal utility of X times the change in X plus marginal utility of Y times Y. And when we hold utility, have you done any of this in math or not really? No, this looks totally foreign to you. From this, when we rearrange this, become marginal utility of X times delta X equals minus marginal utility of Y times delta y. I see that this derivation is totally strange to you. So now we say that marginal utility of x divided by marginal utility of y equals minus delta y divided by delta x at that particular point. And this delta y divided by delta s, sometimes with the minus sign, equals the marginal rate of substitution. So this is just actually elementary math. We call it this full derivative. So we call it partial derivative and full derivative. This is a derivative with respect to two variables, with respect to x and with respect to y. So full derivative with respect to x is essentially the marginal utility, which is the marginal utility of x is actually the first derivative times the delta, the change. And then this is the second derivative, derivative with respect to y times dy. Okay, it's like f prime of x dx, all right? So marginal utility of x is f prime of x, the first derivative. dx is the same as delta x, all right? You haven't studied any of this? So f of x, y, and when you try to take the first derivative, becomes f of x, xy dx plus f of y, xy dy. Is this familiar?
No.
Ah, okay, this is familiar. Well, this is exactly what it is. Marginal utility of x is the first derivative, okay? Is the first derivative. So, you have utility of x, okay? You have utility of x. So, what is the marginal utility? Marginal utility is actually the first derivative. So, marginal utility of x is equal to u prime of x. It's simply the first derivative. So, marginal simply means derivative, means first derivative. Okay, so it's u prime of x, and you can add dx if you like. Okay, dx in this particular case is optional. Is good enough? A few more minutes. Let's see what else we will do. Yeah, I want to go straight to the budget line because it's all about the money, right? Right? It's all about the money. So let's see what is a budget line.
Excuse me.
Yeah?
Is that we all discussed all of this, the properties of what do you call it?
What I'm trying to do now is 5.3. 5.3 is consumers' budget constraint. This is what I'm trying to do now.
But what we discussed before, are they all properties of the consumer behavior?
So far, what we discussed is properties of consumer preferences. We never mentioned the word about money. Or we just said how much you like diamonds versus gold. How much you like apples versus oranges. All we discussed is what are the preferences for a person. Now we say, suppose you have 1,000 real or $1,000. How many oranges are you going to buy and how many bananas? Is it 50-50?
No, I hate bananas.
Huh? What's it going to depend on?
The prices.
Oh, it depends also on the prices. If a banana costs 100 real and an orange costs 1, of course you're going to be buying a whole lot more of oranges, in other words, of the cheaper. In other words, it depends both on your preferences, but also on the prices too. On the prices, by prices, who of course means in this particular case, the price ratio. Alright, so you have 1,000 real, okay? You have 1,000 real, and the price of each is 1. What we call a budget line is simply the set of all points where with bundles that we can afford for the full amount of money. So we put in here 1,000 and we put in here again 1,000. The price is 1, the price is 1. So you draw the line here, okay? And when this price is 1 and this price is 1, you can get 1,000 of the one and 0 of the other. You can get 1,000 of the other and 0 of the first. You can split it into, this bundle will be 500, 500. This bundle will be 250, 750. This bundle will be, let's see, I just want to make sure that I have them right. So actually it's going to be 750, right? 750, 250, because this bundle is 1,000 and 0, and this bundle is 0, 1,000. So this will be 250, 750. So all I'm saying is if each costs $1 and I have 1,000, I can buy any point. I can buy this point here, it's going to be 900 versus 1, right? So if I spend all the money, I will be exactly on this line, right? If I will save some money, I will be inside. Well, remember the original assumption was that I will not be saving and I will not be borrowing. So if I have two goods, I will be spending it all on those two goods, and then I will be exactly on this line, okay? So this is the line which tells me or shows me all possible bundles which I can afford with my budget. In this particular case, my budget is 1,000. Well, the set of all points which show you every bundle that you can afford, we call it a budget line, that's all. So let's write it in big red. Budget line. Well, what happens if the price doubles? Here, the price doubles for this product. What's going to happen with the budget line?
It's going to go up because decrease of the cost.
Okay, decrease by half. So how is it going to shift? What's going to change? Well, try to say it. Now, here's the difference between you and me. I can wave my hand and you're supposed to understand. But you cannot wave your hand, first of all, because it's not visible on the camera. And second, wave handing is not acceptable for you guys.
It's going to rotate.
Oh, it's going to rotate. So if it's going to rotate, you got to tell me two things.
Clockwise.
You got to tell me first, around which point? So which is the center of rotation? And second, you got to tell me the direction, which is clockwise or counterclockwise. So which is the center of rotation? You see how it works now? So I'll give her a bonus point. Let's try.
The center point must be the middle point.
No, it's not the middle point.
Oh no, it's going to be the good speed.
Yes, this is the price which did not change. So, you can still afford 1,000 of these because the price here remains. If you spend it all on it, you can still get 1,000. So, this is the point of rotation. Now you got to tell me how you're going to rotate.
Clockwise.
Clockwise. So clockwise, I'm looking at my watch, goes like this. And how far do I go? How far do I go? 5 degrees, 10 degrees, 30 degrees, 60 degrees?
50%.
Oh, 50%. So, which is the point of intersection? Which is the point of intersection? I'm asking you to figure out. This is 0, this is 1,000. The intersection will be right in the middle. It's going to be 500. Alright? In other words, you can get 1,000 of the one and 500 of the other. So, the new curve will be this one here. So, when the price doubles, it rotates inside and shifts halfway through. If the price quadruples, it's going to go like this, all right? Now, what if both prices doubled?
28. Zero.
No, if both prices doubled, it will move from 500 here, it's going to be
500.
parallel 500 there. So this of course is 1000 and this of course is 500, all right? So this is how the curve shifts. I'm just explaining if the price changes, how does the curve change, all right? And now let's do and show graphically, and we are done for today. Let's show the last piece before we get done is how is the consumer maximizing his consumption? Well, he has, let's say, he has a particular budget line, right? And he also has some consumption bundle. And the first consumption bundle is like this. The second one is like this. The third one is like this. So, what I draw here is an indifference map, okay? And the question is, which is the best possible consumption bundle? And the answer is, he can consume this, all right, or this. But obviously, if he's on indifference curve X, Y, Z, V, all right, if he consumes anywhere on X, he can move his consumption to Y. All right, is that fairly straightforward? Yes. If you move your consumption to Y, remember, indifference curve Y is always better than X. So, as long as he can consume on Y, Y we call strictly dominates X. In other words, Y is strictly preferred to X. So, he can consume any one X or he can consume to Y. Of course, is Y affordable?
Yeah.
Yes, Y is affordable. He can consume here, or here, or here, or here, or over here. All right, so what about Z? Will he consume and get to Z? Is first of all Z preferable to Y? Yes, of course. Z is higher than Y, so Z is further out, okay? That's the first part. And the second part, is Z attainable? Can he actually consume anywhere and get Z?
No,
Just that one point here. That's the point where Z touches the budget line. So, where the indifference curve touches the budget line, in other words, where the indifference curve is tangent to the budget line, you get what is called utility maximization subject to the budget constraints. In other words, of all curves that are lower, you can always improve by moving higher out. And the highest possible indifference curve is the one where the tangency occurs. V is better than Z, right? V is better than Z. But V is impossible. Impossible. And impossible, in this particular case, in English we call it unattainable. 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 In other words, if you try a indifference curve which is outside the budget line, it is strictly unattainable. You cannot get it. It is impossible, okay? So, Any curve which is outside is impossible. Any curve which is inside is possible, but it is also possible to improve. Okay? So any curve which is inside, you could still move further outside and still become attainable. So as long as it is inside, you can get always on a point further out and improve. So if you're inside, you can improve by moving, we call this northeast. In other words, moving upward. In other words, if you're inside, you can increase the consumption of both goods at the same time and improve your overall utility. So, as long as you're inside, you're going to be moving further out and out until the point where the indifference curve is tangent to the budget line. At the point of where indifference curve is tangent to the budget line, you get consumer utility maximization. So, what is the budget line representing? It represents the market rate of substitution. What is the market rate of substitution? It is simply the price of X divided by the price of Y. Okay? The market rate of substitution. Alright? This is the market rate. This is the rate at which you can substitute X and Y on the market at their market prices. And what else did we have about indifference curves? How did we call it? The other one, when it trade off X for Y, how did we call it? How did we call it? From 20 minutes ago. You're all tired, right? Yeah, I can see you're all tired.
Down slope.
Oh, how did we call this slope? Delta X. How did we call this? Delta X divided by delta Y, sometimes with a minus sign. How did we call it? Marginal rate of substitution. So this is the market rate of substitution. In other words, maximization occurs where the trade-off for the person in his mind, for the utility, is identical to the trade-off on the market. Alright? Where his internal trade-off, what he thinks, in other words, how he trades them off is a utility in his brain, is the same as how the market trades off the two different goods. Alright? So, maximization occurs when the internal trade-off, the consumer trade-off, is the same as the market trade-off. Alright? Is this good enough? And I think we're good enough for today. Let's turn this off.